Let's compare these two. So in this slide, I'm going back to the beginning of this chapter. We're comparing first. Guys, I love to repeat things. That's the only way it sticks in here. This is the, look, I don't want to write now. Okay, look, this is the somatic nervous system. Okay, we're going to compare once more the somatic nervous system innervating the skeletal muscles and what we have been describing today, which is the autonomic nervous system, the two branches of the motor division of the peripheral nervous system. So remember, in the somatic nervous system, we have only one neuron in the central, one motor neuron located in the central nervous system, heavily myelinated axons that release acetylcholine in the synapse between this axon and the effector, which is the skeletal muscle always. So this is a voluntary nervous system. We can control the contraction of our skeletal muscles, don't we? And the effect is always going to be stimulatory. These neurotransmitters always are going to stimulate the muscle, the skeletal muscle, to contract. Okay? Now, let's contrast that with the autonomic nervous system. What happens in the autonomic nervous system? Well, it depends. We have, remember, the sympathetic and the parasympathetic branch. Now, in the sympathetic, how do we say this? First, in the central nervous system, we're going to find the preganglionic neurons both in the sympathetic and the parasympathetic nervous system. In the sympathetic nervous system, remember, they are located on the spinal cord segments from forget about it, from T1 to L2. And this is the reason why this system is also called thoracolumbar system. Where is the preganglionic neuron of the parasympathetic nervous system located? Is either located in the brain or in the sacral segments, lateral great horns, both sacral segments from S2 to S4. And this is the reason why the parasympathetic nervous system is also called craniosacral division. Done. Let's see that's the preganglionic neuron. Let's see the preganglionic fibers, the axons of these neurons. All of them are lightly myelinated. They're slow axons. In the sympathetic nervous system, they are short because the ganglia are, if I will have done this before, or if I drew this picture, I will exaggerate this. Okay, so you can see that the preganglionic axons in the sympathetic nervous system are very short because the ganglionic neurons are located very close to the preganglionic neuron. In the parasympathetic system, these axons are very long because the ganglia containing the ganglionic neurons are located very close to the target organ. Okay, this is like first structure, preganglionic neuron. Number 2, preganglionic fibers. Number 3, the ganglia. Where are the ganglia located? Well, in the sympathetic nervous system, remember we have the sympathetic chain ganglia and the collateral ganglia. They are located on either side and in front of the vertebral column. And the other modified ganglia is the adrenal medulla, located on top of the kidneys, and the kidneys are located right in front of the spinal and to the sides of the vertebral column. So those are the locations of the ganglionic neurons in the sympathetic nervous system. In the parasympathetic nervous system, these ganglia are located very close to or within the target organ. okay, right here. So those are the locations of the ganglionic neurons. Now, the synapse, the communication between the preganglionic fiber and the cell body of the ganglionic neurons, they all release, and this is a similarity, they all release acetylcholine. Preganglionic fibers of the sympathetic and parasympathetic system, they all release acetylcholine. Okay? Let's describe now. Fourth element is the postganglionic fibers. The postganglionic fibers in the sympathetic nervous system, again, I will, if you're drawing your pictures, which I highly recommend, exaggerate this so you can remember. Make these really short and these ones really long. So they're really long, and all of these postganglionic fibers are unmyelinated or non-myelinated. So slower, even slower than the preganglionic fibers. Now, these are really long because they need to reach the target organ, okay? And these ganglia are located close to the spinal cord, so it's pretty much, it's a good distance between the two, the ganglia and the target organ. So postganglionic fibers are really long, and they release norepinephrine. Something different happens when the ganglia that we're talking about is the adrenal medulla. We don't have ganglionic neurons in there. They're modified cells, and they produce the epinephrine and norepinephrine too. See, almost the same neurotransmitters, but instead of releasing these in a synapse into the target organ, to stimulate the target organ, okay, these ones are released, since this is an endocrine gland, is released into the bloodstream. So this travels all around your body. This reaction is more localized to wherever organ you are releasing the neurotransmitter to. In here, the effects are going to be widespread in your body because it reaches the epinephrine and norepinephrine reaches the bloodstream, and once in the bloodstream, it can go anywhere and interact, remember, with the specific receptors, only with the organs that have the receptors for these neurotransmitters. Okie dokie. Now, on the parasympathetic nervous system, the postganglionic fibers are short. Why? Well, because we are very close to or right there in the target organs. And again, these neurons release the same acetylcholine. Okay? The effects in both, okay, in the sympathetic and the parasympathetic nervous system, they can be either stimulatory or inhibitory. So this is a big difference with the somatic nervous system. Remember, it always stimulated the skeletal muscles to contract. In here, it can stimulate the skeletal muscle to contract, like, for example, heart, beat, sympathetic nervous system, or heart, relax, and relaxes, okay, or contracts slower. Both sympathetic has stimulatory and inhibitory actions, and parasympathetic has stimulatory and inhibitory actions. And these actions depend on what type of neurotransmitter you are releasing, what receptor this neurotransmitter is interacting with, and the organ there is interacting with. Okay? As the effects, I'm not going to repeat the entire thing, just remember that the effects are opposite, and which means that not every organ, but most of these visceral organs have a dual innervation, meaning that, for example, the heart has innervations or have wires coming from the sympathetic nervous system and wires or nerves coming from parasympathetic nervous system. That's what we call dual innervation. Okay, so nerves coming from both divisions of the autonomic nervous system. When one system is stimulated, the other system is blocked. Okay, if the sympathetic nervous system is acting in the heart rate is increasing and the parasympathetic nervous system is blocked. If we are watching TV, watching this video, eating an apple, I guess, parasympathetic, don't fall asleep, parasympathetic system is activated and sympathetic system is blocked. Okay? The last video is coming up, the last video of this module. And in there, we are going to review just how all of these things, structures that we are described in the autonomic nervous system act to produce a visceral reflex arc. Okay? See you in the next video.